Search me.
Excuse me? How do I point?
Point back.
Forward? Point no. The grid. Okay.
Excellent. Okay, so our final speaker of the session is Vijay Vazirani, and he'll speak about extending general equilibrium theory to the digital economy.
So I want to be able to pace here. Actually, I'm preparing it for the panel discussion. So, I just want to start by saying that I've had an unbelievably thrilling time working in general equilibrium theory for the last 10 years. I think it's the most enchanting theory there is. First of all, it has huge philosophical imports. For one, it ratifies Adam Smith's principle of a free market, and his invisible hand of the market is also ratified. It gives us a way of pricing goods in a principled manner from first principles, and it tells us how to allocate scarce resources among alternative uses in an efficient way, which is the main function of an economy anyway. So it's really absolutely a fascinating theory, and of course the ROW theorem is the crown jewel inside this theory itself. But about a year ago, together with my student Kamal Jain, we managed to find a dent in this theory, believe it or not. And the dent is that it doesn't work for digital goods. Okay? But we also managed to repair the dent to some extent in, I think, a very clean and natural way, and that's what I want to show you today. Okay, so I'm going to always talk about Irving Fisher's model rather than the ROW model. It's a sub case of the ROW or the Walras model, but it leads to some simplicity which is good at this point, because we are delving into a slightly new avenue here. So just to remind you what the Fisher model is, we have a bunch of buyers that came to the market. Each one has their own utility function and their own money, different for each person. Utility functions could be whatever, let's say a non-separable, concave, so on and so forth. These are all the buyers, as you can tell. And there are a bunch of divisible goods here in the market. And we know how much of each, but we can rescale the quantity of each good and call it 1 unit. You know, if there are 50 gallons of milk, we can call it 1 unit. We can define our own unit, okay? And the whole question is, are there prices P1, P2, P3 for these goods? So that if each of these people is given an optimal bundle of goods relative to these prices and for the amount of money that they came to the market with, then they go back with an optimal bundle, and the market clears, which just means that every good is sold to the last drop because it's all divisible, and every money is spent to the last cent. Okay, so that's a market clearing condition, and these prices are called equilibrium prices, and they exist. That was the ROW theorem. That's the conventional economy, but now we are rapidly changing to the digital economy. And unless we extend this beautiful theory to that economy, we won't have the same feeling of at least guarantee that we are doing things properly. And surely trillions of dollars are at stake here. We don't need any more applications than that, hopefully. Okay, so digital goods. What are digital goods? Goods that can be stored in the memory of a computer. And we want to price digital goods from first principles just the way we priced conventional goods. And by now there are lots and lots of digital goods, all the way from music, movies, video games, cell phone apps, web search results, so on and so forth. And the point is that once a song is written, you can make any number of copies of this song. So supply is infinite. If supply is infinite, price should be 0. If price is 0, nobody will write the song, and you won't have a digital economy, and we'll go back into a huge, deep recession. So we don't want that to happen. Okay, so how should we price these? From first principles. Another interesting observation is that similar to what Norm made about his work, that the only Pareto optimal allocation in the setting of digital goods is that everybody should get one copy of each digital good, because you can give it to them. And that's the only Pareto optimal allocation, but that's obviously not the allocation we are looking for, right? That's meaningless, right? We want to actually sell it for some money, not just give it away to everybody, okay? So the usual notion of equilibrium is simply not applicable, QED, just the way Norm did it for his mixed Nash equilibria. No, it's in both. No, it's in both. Please, let me come to that. It's a good question, but it's in both. What we will do here is we'll redefine supply and demand for digital goods, and I will show you how to map this economy to the ROW model, okay? And I'm leaving this map under quotes and deliberately vague, and just to say that it's not a reduction, and you'll soon see what I mean by a map. And then we give a notion of equilibrium, show existence of equilibrium using Kakulani fixed point theorem. And there's a preliminary algorithm for one preliminary case. It's not a very satisfactory state as far as algorithms go. But the rest of it is on solid ground, I think. So, digital goods. Even ideas are digital goods, okay? And at this point, I want to relate to you something very, very interesting that happened. Namely, last year when this work was done, more or less, I had the opportunity of sitting down with Professor Arrow for 2 hours, getting very detailed comments on this whole work. And then he gave me, he told me a fascinating story about ideas, something that he's been thinking about for a long, long time, how to price ideas. Okay, so say tomorrow, if you get an idea, a new idea for making bread more efficiently, and you want to sell it to many, many bakers, how much do you charge them? Okay, so here's the story he told me. So apparently, Coca-Cola company in the 19th century used to exist, but they used to sell their drinks through what was called a soda fountain, which existed in drugstores. And there was a guy sitting next to this fountain. He had a name, I recently found out. He was called the soda jerk. And the reason is that when you gave him some money, he pulled a certain lever, and out came some carbonated water and some syrup and into a glass, and you drank it and you gave him the money, right? That was the purpose of the soda jerk. Now, one fine day, this guy comes to the owner of the then Coca-Cola company, and he says, you know, I have a fabulous idea to totally revolutionize your company. I'll give it to you, but give me the right price for it, okay? And obviously, he had to tell him the idea first and then get the money, right? So the owner apparently said yes, and then this guy gave him a slip of paper with 2 words written on it. It said, bottle it, okay? And that totally changed the company, of course. And at that point, apparently, he was given 50K, which I don't know how many millions it translates to today. But that was the question was, how was that 50K arrived at? What should have been the price of that idea, that 2-word idea written on a scrappy piece of paper, right? So, I mean, these are deep questions, obviously unanswered right now. But just to tell you that this is a fascinating realm. There's a whole lot of things to do, and we have just put a little patch on the dent so far. Okay, and let me actually show you the patch before we are done today. So we'll start by studying the digital realm a little bit to see what kind of model naturally fits in here. And the first thing to realize about digital goods is that you don't have 31 types of one good, like 31 flavors of ice cream or 15 flavors of yogurt. You have 9 million songs on iTunes, okay? It's orders of magnitude more. 300,000 apps on the iPhone store, okay? Now, if that is the case, then sorry for saying this at the rationality center, but full rationality and infinite computing power go out of the window. You simply cannot price songs individually and expect somebody to go through this 11 million long list of A for 123, B for 156, C for 356, and say what is the best song, which song gives them the best utility per dollar, and pick that song. That's simply not possible. Okay, this kind of infinite patience and so on and so forth is not feasible. So we have to change. We cannot price songs individually. Okay. Okay, and what has happened is that among digital goods, at least among the four, I mean, CDs and DVDs can be considered as forerunners of digital goods because the CD can obviously be stored now on a computer. You have seen uniform pricing emerge. For CDs, there are CDs for $5.99, $9.99, $12.99. I don't know. There are a few prices. DVDs, same thing. And on iTunes, they started with simply uniform pricing, 99 cents for each song. And now, recently, they went to three categories of 69, 99, and 129. Okay, so that will be the first criteria in our model, that we should have a few categories of digital goods. Okay, then categories may have meaning, like jazz music, children's music, and classical movies, or they may be simply syntactic, like good music and bad music, if you want, or premier music and substandard music. And each of these categories will be priced. All the goods in a category will have the same price. Okay, so uniform pricing of all goods in a category. And I'm going to call a generic good in a category a song, quote unquote song. But okay, so with that assumption, there are many questions left. How do we price categories? How do we allocate goods from categories? What is the notion of equilibrium here? Okay, so for that, let's jump into digital goods a bit more and understand what they are all about. So a person desiring two units of bread, okay, is happy if you give them one slice of rye and one slice of whole wheat. It doesn't have to be. Oh, sorry. Moreover, sorry, they are not only happy with one slice of rye and one slice of whole wheat, but also with two slices of whole wheat. Okay, but a person desiring two songs has to be given two different songs. Okay, not two copies of the same song. Okay, so that's a big difference. Another difference that comes about when we talk about production, which I haven't introduced yet, is that when you make a loaf of bread, the world is better off in some sense. When you make a copy of a song, well, not really, unless you make a really new song, which is a different matter. So, yet more. Now, in digital goods, what happens is that people have very, very different liking for songs in the same category. Okay, some people love these songs, and some people hate these songs, and another person may be, completely the opposite. Okay, and we have to certainly take this kind of a thing into consideration. Sorry, is there a question there? Question? No. Okay, I was wondering what it's about. Okay, so here's more about the model. So I'm going to assume that there are G categories of digital goods, and I'm going to assume that Sj is a set of songs in category J, okay? And in some sense, they define the category J. And you'll soon see why I say that they define the category J. And intuitively speaking, if I have a category called classical music, I cannot put some thing that's basically noise in there. Otherwise, it'll ruin the whole category. And there are good analogs of the same thing happening in the usual equilibrium setting, where if the instance is ill-formed, prices can be zero, and we can go into that a bit if you want. But anyway, so we have assumed there are G categories of digital goods. Sj is a set of songs in category J, and the most important new thing here is that for each category, each agent has a total order Tij over all the songs in this category, saying how well they like the songs in that category, and it's a total order. Okay. Now, here's more on the market model. I'm going to assume one conventional good, and I call it bread, just to show you that in this model, a conventional economy is built hand in hand with the digital economy. You could have put instead of one good, you can put any number of goods here, but that's just for illustration. And there are G digital categories. And now each agent has what we call a coarse utility function over the G digital categories and bread. So the function goes from R to the G plus 1 to R, saying how much happiness this person got from an allocation. And this person has money MI as in a Fisher market. Okay? And here's how this person is given an optimal bundle of goods at prices P. So at prices P, you first compute her course allocation. So using by knowing how much money she has and her utility function and the prices P, you can find the optimal amounts of bread and the number of songs in each category. And then for the songs, you go into that total order and pick out her most favorite Xij songs. And that gives us the detailed allocation for this person at these prices. Okay? So that's all quote unquote definition. Okay? And we are going to assume strict copyright laws so that it's not the case that if I sell this song to this person can start selling this song. That's not allowed. Yeah. Sorry? This one or the next one? FI is a utility that this person derives. Right, by song. So you say, okay, I'm so and so happy with so if I get so many songs and so many movies and so many iPhone apps, I'm so and so happy. Okay? And here you just take into consideration the numbers of songs and movies and iPhone apps. Now, which ones they will be in your application? Well, they'll be the best ones that you want. When you are given an optimal allocation, you will be given your most favorite songs in each category, as it should be, right? If you went to the market and you saw 99 cents on each song, you'll obviously pick your most favorite ones. So the equilibrium concept should give you your most favorite ones. That's the reason for defining this total order in the first place, right? G is the number of digital categories. I'm saying it's fixed for an instance. Over categories, of course, because they are uniform in each category. They are not over goods. They're not over songs, sorry. Okay, so strict copyright laws are assumed. And here's a very basic difference between this model and the ROW model. Namely, in ROW model, any allocation is a valid bundle, okay? So however much milk and honey and cheese you got, that's a valid bundle. In our model, because of these total orders, not every bundle is valid. So for instance, suppose that this buyer I has a total order A, B, C, D, E, okay? Then for her, AE is not a valid bundle, but AB is, because if she wants two songs, she wants these two songs and not these two songs or not these two songs, okay? And this immediately says that there's no reduction from our model to the ROW model. So because you cannot simply use the ROW. Yes. ABCDE are songs in the total order. So suppose the category has 5 songs, A, B, C, D, E, and this person likes A to B to C to D to E. Now, if she wants 2 songs, then she wants. Huh? Yeah. Okay, I'm assuming that. No, Tij is a total order. So Sij is a set, and Tij is a total order of buyer I on Sj. So perhaps I should have said that here the set is set A, B, C, D, E. Yeah. Okay. Oh my God. Okay, we'll come to that because I have 10 minutes left. Let me. Sorry? So I can go on, right? Oh. Okay, so this model cannot be reduced to ROW model. But let me show you what our mapping is, quote unquote mapping, and you'll see why I call it a mapping in a moment. Okay, so suppose we have, this is our allocation of the available amount of bread, which I've called 1 unit, okay, happens to be 2 loaves, okay, and this is sort of equivalent to the total number of songs we have in this one category, okay. Now, we know that this business of divisibility is all hokey pokey, and at the end of the day, nothing is divisible, and basically there's some indivisible part in bread, maybe it's a molecule for all we know. Okay. Anyway, so this molecule here is equivalent to a song, more or less. And when you assume divisibility, you assume that you can even break this molecule, and we have to assume that songs can be bought fractionally, otherwise there is no equilibrium, period. If as Noam said, discrete goods is not a very nice setting for proofs of equilibrium. You don't get continuity, you can't apply big hammers like Kakutani fixed point theorem. So we'll assume that songs can be sold fractionally, okay? And at the end of the day, you want more like 50 songs. It's not like buying a house or a car. You don't want lots of songs, so you know, rounding up or down is not that tough. Okay, so here's the mapping, and this is the key slide in the whole thing. This, in one thought, should give you how this model relates to the normal model. Okay, in the usual model, each molecule of bread can be bought by at most 1 buyer. Okay, in our model, each song can be bought at most once by each buyer. Right? This is an obvious statement, right? In the usual model, each molecule of bread can be bought by at most 1 buyer, and equilibrium says that every molecule should be sold off, right? Here, each song can be bought at most once by each buyer, because you can make any number of copies, and of course nobody wants 2 copies of the same song, okay? So let me use this mapping to tell you what supply and demand, the definition of supply and demand will be. So for conventional goods, the fact that you don't have a deficiency just says that the amount of goods needed in the equilibrium is no more than the amount there is, and that there's no surplus says that the amount of goods needed is at least the amount of good there is, right? And so that leads to equality. In our case, no deficiency says that in any category, nobody demands more songs than there are in the category. Okay? So remember, once you apply the coarse allocation function, you are told how many songs this person wants from this category. And if that person wants 52 songs and the category has only 25 songs, we are in trouble. Then the prices are not right. Equilibrium has not been achieved. And equilibrium means that nobody wants more songs than there are in a category. And no surplus says that for each song, there is a buyer that buys this song fully, 1 full copy, which is not the same as 2 buyers buying half a copy each. And you have to worry about that because we are assuming that songs are also divisible goods. Okay, and from this I can now summarize the notion of equilibrium. So prices and allocation are equilibrium if each agent gets an optimal bundle. And by this, I mean the detailed allocation, right, including the right songs. Nobody demands more songs than there are in a category. And the market clears, which means that all the bread is sold, and at least 1 full copy of each song is sold. And you may say, why 1? Why not 2? Well, at 1, we can prove existence of equilibrium. At 2, there may not be. And the reason is that after having sold 1 copy of each song, to be able to sell a 2nd copy of each song, you may lower the price, and thereby somebody may demand more than FJ songs, and you simply don't have equilibrium. So 1 is the natural and the only possibility here. And that's the market model, and equilibrium exists, and it takes a fair amount of work to reapply. I mean, it has to be done from scratch. It's not a reduction. And here we have to assume the notion of a market maker who consumes surplus songs and produces deficient songs. But at the fixed point, the market maker does nothing, so it's a fictitious entity That's just there for the proof. And we can show everything for ROW model with production. And if Kevin wants to be on the panel, he has to give me some more time. What?
It's a win-win situation for me. I get off of
You won't be off the panel?
We'll see how you do.
You're fired. Okay, so I won't go into the production model because there are so many other interesting things to talk about in the 7.5 minutes he gave me. No? Okay, 5 minutes he gave me. Okay, so so first of all, we want to go to, I mean, this is absolutely simple model, and the reason for that is to just make it work. Okay, make the proofs work down to the last dots and crosses, whatever it takes. But we want to go to more complex and realistic models where we have complementarity in production and perhaps even complementarity in consumption, because maybe when you buy a movie, which movie now my son sees, what is that called? I'm out of neurons, sorry? J.K. Rowling's movie, what is it called? Harry Potter, yeah. When he wants to buy a Harry Potter movie, of course he wants the Harry Potter book also. And so, you cannot say, okay, you get this best movie, but that best song, okay? Anyway, economics of ads in digital marketplaces. I mean, this is an amazingly difficult question, amazingly important today because of everybody is, half the people here are working on this from some other angle altogether, but the economics of these ads, say Google ads, is totally ununderstood. Creation and extinction of categories, algorithmic questions galore, many, pricing of financial advice. Now there you don't want to sell it like a song, because then it'll be useless if everybody goes and buys Microsoft or something. So how should you price those? How should you price innovative ideas? That's the old brainchild of Ken Arrow. Very difficult question. Pricing of drugs. Well, drugs also are like digital goods in the sense that there's a lot of research that goes in, but to make one more pill costs nothing, right? But of course, drugs are not substitutable. You cannot take this instead of that. You can listen to this music this song instead of that, but it's a very different kind of a realm. Other natural models that don't rely on game-theoretic assumptions of rationality, and because I think this is a natural model what we have. Are there others? That's it. So I finished, and he can be on the